Roteple's question, let's go and look at it and then help you to understand what you would need to do if you had this kind of a question, maybe in your exams as well, right? So this question is a question that involves a right angle triangle. You will notice that these are very popular questions in trigonometry. Trig has got 7 subtopics and this one is basically one of them, right? And you will notice that we've got a terminal ray that lies in the 3rd quadrant. And we are told in that opening statement that P is a point with coordinates -1 and -3, which confirms the fact that P does indeed lie in the 3rd quadrant because both the x coordinate and the y coordinate of that point are lying on where x and y are negative. So this is basically where x is -1 and the y value is -√3. So that's the point on that terminal ray OP that you're looking at there. Now we are required to calculate the sine of 2 theta without using a calculator, right? Now what you need to understand is most of the trigonometry that you guys need to worry about was covered in grade 11. Right? Because you're watching this show, we'll keep reminding you and dragging some of the stuff from grade 11 to help you to understand how does grade 11's work interact with what we have to do in grade 12. In grade 12, the only thing that is new is the compound angles and the double angles. And the fortunate thing about what is going on here is that you are given in the formula sheet those double angles and the compound angles. They add them there. So you don't have to worry about memorizing them. If you know them, right? If you know them, it helps you to identify them. When you're looking at a question, you can see that this is a particular compound or this is a particular double angle. So the relationship between what we did last year in grade 11 and what we're doing now in grade 12 is we just want you to apply the formulae of the compound and double angles and integrate them with the concepts of grade 11 to try and solve questions. So the interest is not application, not proving them. They might ask you to show a particular result is true, but what is most important is applying the compound and the double angles. So we will give them to you in the information sheet. You can refer to them, but what you need to know is how to use them. So let's go check what is going on here. We know for a fact from the information sheet that the double angle of sine 2 theta can be expressed as the sine of 2 theta is equal to 2 sine of theta multiplied by the cosine of theta. This is what we basically know, right? Now, if you look at what we have here, by definition, from as far back as grade 10, we know for a fact that 2 is a number, but the sine of theta is always given by the opposite side divided by the hypotenuse side of a right-angled triangle. Some people imagine that as sine theta being y divided by r, right? And then the cosine of theta is also known to be the adjacent side divided by the hypotenuse side of a right-angled triangle. That basically makes it to be x divided by r, if you remember from as far back as grade 10 swag. So for me to be able to find the solutions to this, I need to build a right-angled triangle and then find all the sides of that particular triangle. If I can be able to do that, then I'm just going to come and paste all that I have on that triangle in this formula that I've just written down here. And that should help me to figure out the solution to what is going on. So what we need to always do is go to that diagram that I did for you there, which is happening to be in the 3rd quadrant now. And you go and you construct a right-angled triangle that is simply going to look like what I have now. And then I'm going to basically name all the sides of this right-angled triangle. You will agree with me that the x value was given to us as -1 from the point that was given to us that the x coordinate is -1 and the y coordinate is -√3. So I can simply write -1 as the side of that rectangular triangle that I have there. And then on the y-axis, we also have -√3 as the side for y. Now you will notice that we are missing one of the sides, and it's always the case that you will need to figure out what is the hypotenuse, which we normally call r in this case. And if you remember very well, Pythagoras told us that r squared can be found by x squared plus y squared. And I was there when Pythagoras said this, right? Pythagoras said r squared is x squared plus y squared. So if you sub your x value, which is -1 squared, and you sub your y value, which is minus the square root of 3 squared, and then you work this out, that's going to be 3 plus 1, which is 4. So your r squared is 4, and then the r value is going to come out as +2. Remember, for x and y, x can be negative and y can also be negative or either positive, but r will always be a positive value. So I got my r value as exactly equal to 2. Now when I've got all these x's and y's and the r's, I can then come with all the information that you have and substitute these on that formula of the double angle that you have. The double angles, you get them in the information sheet. You just want to apply them. Keep that in mind. Right, so I'm going to take these info and then substitute on my diagram. What is going to be the case now? We're going to have 2, which we've been looking at for a while now. And then our our y value according to the diagram is minus the square root of 3 divided by the r, which is 2, right? And then the x value is minus 1 divided by r, which also happens to be 2. And if you simplify this further, you'll notice that we can say 2 cancels 2, and then you'll just have positive square root of 3 divided by 2. So the final answer to this question is going to be equal to the square root of 3 divided by 2. And that will be the answer for the first question of sine 2 theta. Right. Now, the next part of this question is very exciting, which is the part that says, for number 2, we need you to find the cosine of half theta. Right. So now we have to understand something very interesting about this. This is when math becomes complicated because they want you to now get out of the box. Right. There is no formula we have in high school for half angles. If your teacher likes you enough, they're going to show you how to work with half angles. But we want you to understand, how do you take the knowledge of a double angle and manipulate it to give you a half angle in this case, right? So we are going to use a double angle and try to reverse ourselves back so that we can get a half of an angle. So let's see what will happen here. We know for a fact that we are looking for cosine of half of an angle. So I'm going to take the result that we know from the information sheet. We know from the formula sheet that the cosine of 2 theta has got 3 versions. You can choose any of those 3 versions. You can write it in terms of sine. You can write it in terms of cos. You can also write it in terms of both sine and cosine. Now, since the question that I'm dealing with is asking me about cos, it is wiser for me to write my compound or my double angle for cosine in terms of cos. So I'm going to choose the one that says 2 cos squared theta minus 1. Someone is probably wondering, why am I picking the double angle of cos in terms of cos and not in terms of the other 2 versions, which is the cos squared minus sine squared, or the one of 1 minus 2 sine squared. I'm picking this one because the question that I'm dealing with is dealing with cosine, because I'm going to think about it like this. I want that to be featured there. So since my question is in terms of cos, I'm going to pick the cos version of this expansion. So if you continue here, you will notice something very exciting about what we have. I am going to now change my theta. I'm going to call it half theta. I'm going to change that and call it half of whatever you're looking at. Right, so which means if you divide here by 2, if you divide the angle by 2 here, if you divide the angle by 2 here, you can also divide this angle by 2 that you are sitting with right there, which makes this to basically be the cosine of theta is simply 2 cos squared theta over 2 minus 1. So this is how you manipulate a double angle to simply be in terms of a half angle. You divide both the double part and the theta part in terms of whatever the ratio that you're looking for. In this case, we wanted it over 2, so this is basically what we end up with. And then after here, we are looking for the cosine of that. I'm going to try and make cosine the subject of the formula. So you take 1 to the left. So you're going to have the cosine of theta plus 1 is equal to 2 cos squared theta over 2. Now, I'm attempting in this case to make the cos of half theta the subject of the formula. And then you'll notice that we can divide both sides by 2. Now, if I divide on the right-hand side by 2, I also need to divide this side by 2. That will simply remove this 2 for us. We will then have the cosine squared of theta over 2 is simply the cosine of theta plus 1 divided by 2. Now, that's a square right there, beautiful people. We don't want that because this is a square that you need to keep in mind. We can remove that square by taking a square root on both sides. So in conclusion, this is simply going to look as follows. We will now have, if you take the square root on both sides, it will eventually say the cosine of theta over 2 is basically the square root of the cosine of theta plus 1 divided by 2. Now remember, we take plus and minus, so it's important for you to keep that in mind. It's actually plus minus because every time you take a square root, you need to always make sure you take the plus and the minus version of this. All right, and then if you substitute what we know, this is going to be plus minus the square root of something very exciting here, which is going to be the cos of theta. If you go to the diagram and we check what is cos of theta, because that can be found from the diagram. By definition, cos of theta is x over r, and we know from our right angle triangle that the x value is -1 and the r value is 2. So our cos is going to be -1 divided by 2. So that's what I'm going to substitute here for cos of theta. That's going to be -1/2. We need to add that. We need to add that to a 1 and divide that by 2, and then try to find a solution to this. So I'm going to call my calculator now to come and assist me in terms of figuring out what is this. So this is the square root. Let's get to the square root first. I have got here 1 minus half is just a half. So that's actually, if I can put it this way, so you guys will be convinced that I'm not making anything up, plus 1. Divided by 2, and then you press the equality sign, you get exactly a solution that says the answer has to be a half. So this is simply going to be plus minus 1 over 2. Depending on what you're working with, you can then decide whether the answer has to be plus half or it has to be minus half. Right. Now, let's go to the other part of this question that was sent to us and see what is going on here. Now, these are questions that are actually asking us to apply the compound double angles in context of a question. So you will notice now that because we know what they are and how they look, we're going to run through this as fast as we can, and you will not be able to, you won't be lost when you're looking at this, right? So we want you to see what you sent to us and understand how do you actually work with this. So this is actually like a drill of some sort. Like, what you're trying to do, a lot of them, right? They're asking 4 of them in total here, and we want you to see how do you actually work with them. I might not do all of them because I want you to see the ideas, then you can be able to answer the other ones on your own when you are at home. So let's see what the story is going to be here. The number one, the first one that I see here, the sine of 2 times -45. It looks like a double angle, right? It looks like a double angle. But 45 degrees is a special angle, and if I double that, right? If I double that, this simply looks like sine of -90 degrees, which also happens to be a special angle which we know the value of. And this is going to be as good as negative sine of 90 degrees. And this one doesn't even need anything funny in terms of trying to expand and finding a lot of things. The answer will just simply be -1, because sine 90 is 1, and then there's that minus outside. So don't let that double trouble you. It's just doubling of 45 gives us 90, and then we can be able to reduce that to negative sine 90, which gives us -1 as a solution. All right. Now, the other part that I'm going to pick here is the second one. What does the second one say to us? We're given the tan of 690 degrees and the cosine of -510. Now, this one is an interesting question, because when we've got the tangent of 690 degrees multiplied by the cosine of -510 degrees, and we have to simplify this, you need to pay attention to something very exciting, and this is the fact that we are not used to working with big angles that are more than 360. What we have decided to agree on as far as reduction formulas are concerned always lies within the first revolution. So if an angle gets to be too much, if it goes beyond 360, just subtract 360 and try to bring it low. And if an angle is negative, which means it's below 0, you then add 360 to bring it back, so that it's something that you will be able to deal with, because it's going to look like what you've seen before, something familiar. Are you okay with that? Very powerful. So my 690, I feel like 690 is too much. So on this number, I'm going to subtract 360 degrees to try and downsize that. And then on this one, I'm going to simply add 360 degrees and help you to figure out the solution on this one. We'll see what is going to happen until we have it where we want it to be. We'll keep adding 360 and add 360 again until it becomes what you want it to be. So let's start first of all with the one of 690 degrees. So if you say 690 and you remove 360 on there, you're simply going to get 330 degrees, right? So that's going to be the tangent of 330 degrees. So I'm going to say this is as good as tan 330 degrees multiplied by the cosine. Let's go to that one. I'm sitting with -510, and if you add 360 on it, you're simply going to have -150, which is still not good enough because it's still negative. You add another 360, it comes out with 210 degrees. We're happy to see that. So this is going to be the cosine of 210 degrees. And then from there, it's just a simple question of asking yourself, in which quadrant does 330 lie? You'll agree with me that 330 degrees lies in the 4th quadrant, so we can just simply use 360 degrees minus something, right? So this is the tangent of 360 minus 30 multiplied by the cosine of this one is 180 degrees plus 30 degrees is going to give us 210, and you'll simplify. This is going to be negative tan 30 degrees if you're using reduction formulas, multiplied by the cosine, which is going to be negative the cosine of 30 degrees. Negative times negative is positive. The tan can be changed to sine 30, which is not necessary, over the cosine of 30. I'm just making a meal out of this because I can see that cos is appearing twice and it's the same angle, so that will cancel out. You're dealing with the sine of 30, which can be written as the square root of 3 divided by 2. Very powerful indeed. And then the last one that I'm going to do here, because they're all the same, you just apply your compound and double angles to find the solutions. I'll answer the third one because it's also a nice question, since this is basically talking to us about a double angle that needs to be manipulated. It is the sine of 22.5 and the cosine of 22.5 degrees. Very powerful. So I'm going to take that down and we're going to see what we can do with it. We were told here that we now need to simplify the sine of 22.5 degrees multiplied by the cosine of 22.5 degrees. Right, now when you look at this, you will notice that it looks almost like our double angles that we've seen before. This looks almost like the expansion for the sine of 2 theta. That's why it's important for you to know them, because you can identify them. It looks almost like the expansion of the double angle of sine, which is basically 2 sine theta multiplied by the cosine of theta. If you look closely, you will see that we have this part. We have this part. That's what we're looking at there. Sine something, cos something. It's exactly the same as what we have there. What we are missing is that 2. We are missing this 2 here. This is where the problem lies. So because we are missing it 2, I'm going to add it there because we can't convert what you're looking at into a double angle without the coefficient of 2. So what I'm going to do is I'm going to put the 2 in front of that sine of 22.5 degrees cosine of 22.5 degrees, right? But if I do this, I need to neutralize that, because what I just did, I'm going to have to neutralize by adding a factor of half there. And you will notice that half of 2 will simply give us the original coefficient of 1 that was there. So this that you're looking at here is indeed that one that you're looking at. Half of 2 is exactly equal to the one that came with this question. So if I continue to simplify further, I'm going to just ignore that half, and I'm going to now focus on this part, which is the double angle part. And that is the sine of 2 into 22.5 degrees. So what is 22.5 times 2? You will see that if you go to your calculator and you say 22.5 and you double that, what you simply end up with is 45 degrees. So this is simply going to become half of the sine of 45 degrees, which can simplify to half of the square root of 2 divided by 2. So the final answer is the square root of 2 divided by 4. And that should bring us to the end of this beautiful question that was sent to us.